Okay. Yeah. So you see, last time we were looking at this games on graphs. Right? Games played on graphs. Right? And the feature was that these games were infinite. Right? Infinite. And what were the other features? Maybe there were two players, right? And let me mention here. So at each stage, game was or is on a vertex. Okay. Should be mentioned earlier, the game, or rather, the graph is partitioned, right? Or maybe better to say the vertex set is partitioned. So can anybody recall how the vertex set was partitioned? Yeah. This is the vertex set V was partitioned into. This is just some language. Okay, it will just help us to write the algorithm in a condensed way and think clearly and so on. So this is one notation which is used in the book, but I usually prefer this notation. Yeah, disjoint union of two vertices, two sets. So what does this mean? It means that this is a set of vertices for player 0 and this is a set of vertices for player 1. And for player 0 means that if the game is on that vertex, meaning you may imagine that a token is at that vertex, then player 0 can only make a move. And player 0 has to make a move and only he can make a move. And move means that he can go to some other vertex which is connected by edges, which has edges to that vertex from this vertex. Okay, it's a directed graph. Okay, so this is something that we need to know. And another thing that we need to know maybe is the run, because today's algorithm will involve run of a game, right? So run of a game. So again, can anyone recall? So because it is not just pure memorization going on here, right? Run of a game, you know what intuitively it means and how we had connected it to make a mathematical definition. So what was run of a game? So it is an infinite game, right? So run of a game would be just a sequence of vertices, right? Yeah, sequence of vertices, which just basically means that this is an element in this set, in this infinite Cartesian product. Okay, this was a run of a game. And for our purposes, every game will have an output which is either 0 or 1. In today, these are the games we'll be considering in which output is either 0 or 1. So output of a game, right? So when you play a game, you have the run, and then you have output of the game, right? So output of a game will be defined as something called a payoff function, right? So that is also important. So let's note that down. So we have, so then we can refer to this later on, right? Payoff function. So what is a payoff function? A payoff function is a function from, so what should be the domain of this? So remember, every time there is a run, there is a payoff function. Yeah. So what is it? What should be the domain of this? Right. Am I getting a call? Yes, please let me know.
Is
Yeah.
it the vertex?
Yeah. Yes, sir. Feeds into the vertex set B.
It is not just the vertex set, right? It's based on a run of a game. Anyways, just think about it and give me a minute.